Good morning. Today's topic graphs in Newton's equation of motion. There are three graphs mainly: displacement time graph, second one is velocity time graph, and third one is acceleration time graph. For that, this is x-axis. For every time is time is x-axis, displacement, velocity, acceleration is on y-axis. For this graph, mainly two topics. One is slope has to be found, which gives the correct relation between the x-axis and y-axis. So slope is equal to y by x. And second one, which is area, which is the area bounded by x into y. So first, in displacement time graph, where slope is equal to y by x is equal to s by t is equal to v, which tells velocity, and area is not possible. And then second, velocity time graph, m is equal to y by x, where velocity by time equal to acceleration. So it gives acceleration, and area equal to velocity into time, velocity into time. So this gives displacement. This gives displacement. So this is another method. So here for velocity ms minus 1 into time s gives meter, which for displacement. And for third one, acceleration time graph, m is equal to y by x equal to y-axis, which is acceleration, a by t, which is called jerk or jolt. It has a unit of ms minus 2 by s equal to ms minus 3, which is have to noted here. And area equal to a into t, which gives v, velocity. Okay. And another important one is the positive of slope gives positive direction on the graph, which is to the right hand side, and negative of the slope, which gives negative direction on the left side or down. This is right both, which are some basic things. So first, some graph. So first, the particle at rest. Particle at rest. So particle at rest, which gives where displacement s equal to 0 or s naught, where time is not equal to 0. So the particle at rest gives like the graph like this, where m equal to 0. Here m is equal to s by t or v equal to 0. Next, this graph where v equal to 0, here v equal to 0 and t not equal to 0, so the graph along the axis. Here slope m equal to v by t equal to 0, so a equal to 0. So here a equal to 0. Next, for second, uniform motion. Uniform motion. Next graph method is uniform motion. Uniform motion. For uniform motion, let us consider a particle moves like this. Here m equal to positive, so where m is equal to y by x or s by t equal to v. Here v equal to positive and constant, not increasing or not changed, hence a equal to 0. Therefore equation s is equal to ut plus of at square becomes s is equal to ut. Okay, then we have to substitute this here, where a is equal to 0, where a equal to 0, hence here v equal to positive and constant. So v equal to positive and constant, equal to positive and constant. Here m is equal to v by t equal to 0 equal to a, hence a equal to here 0. So equation becomes v equal to u plus at, where a equal to 0, v equal to u. Here a equal to 0. Next, here is uniform motion in positive direction. As it is reverse direction, in negative direction, when a particle is like this, movement is like this, here the slope m is equal to negative. So m equal to negative, here v in negative direction, hence a equal to 0, because v is also constant, the particle moves in negative direction, here come to this velocity time graph, here where a equal to 0 in negative v direction, hence v equal to constant in negative direction, where a equal to 0 or m equal to 0. This equation explains this. Here also m or a equal to 0. Okay. Next, for acceleration, this also where a equal to 0, simply a equal to 0. For the next graph, for non-uniform motion, non-uniform motion, which describes increasing. What will be increased? Let us see. Okay, first the graph we are discussing like this parabola. So here m equal to positive and increasing, here m is equal to S by T is equal to V is increasing, hence A is not equal to 0. A is not equal to 0. Hence the particle speeding up or accelerating, and the equation becomes S is equal to ut plus of at square for the displacement time graph. Okay, then here, so m is equal to v is now a is not equal to 0, so a is accelerating, hence v is increasing, hence the graph like becomes like this. Here m equal to v by t, and this slope gives constant, and m equal to positive. Here the initial velocity u, is equal to 0, and the equation hence become v is equal to at, u plus at, where u is equal to 0. Hence for a, for constant, m is equal to v by t, m equal to constant, so a equal to comes like this. So a equal to constant, where a equal to positive and m equal to 0. So next, this equation, this graph becomes like this. Here the acceleration decreases. Here m equal to negative, the slope is equal to negative, that is v is equal to negative, or s by t is equal to negative. The distance decreases as the time increases, so distance decreases as the velocity decreases, so slope decreases. So this is called slowing down. So velocity is decreasing, negative, so a is not equal to 0. Here acceleration is not equal to 0 or not constant, but in negative direction, velocity equal to in negative direction. Hence this velocity will be like this. Here m equal to a, and which is equal to positive, Here m is equal to positive, therefore m equal to 0 and a equal to positive. Next here the graph like will be like this. Here m equal to s by t equal to v equal to positive. As the distance increased as well as time increased, both increased, v will be somewhat positive. So s is equal to ut plus of at square as the equation, and here the slope will decreases, because whenever both the term increases, where time also increases as the distance increases, at the maximum level the time will be constant, the time will be increased and the distance will be constant, so hence there will be a decreasing slope. For this equation, decreasing slope, hence v will be positive, so the graph will be like this. Therefore m equal to negative, here m equal to a equal to v by t will be negative, therefore v is equal to u plus at, and s is equal to ut plus of at square. Here a is equal to negative, so here a equal to be negative and a equal to constant, and finally one more graph is like this. Here m will be negative, it is called speeding up, speeding up, and m equal to v equal to increasing. As the graph goes like this, and here m will be negative and m equal to a will be negative. The equation a equal to negative constant. So these graphs are non-uniform motions. Okay, thank you.